Hello, everybody. Welcome back to the Intellectuary channel. Today's topic of discussion is all going to be about the derivative and the tangent line, and this is going to be part one of this concept. So, these concepts, right, the derivative and the tangent line, are really crucial to understand, contextualize, and to be able to apply in terms of when given any mathematical equation or question or anything within the AP courses. And everything kind of starts from this foundation of derivatives. And so understanding these concepts is going to be crucial for the mastery of AP calculus. So let's just dive right into the video. So in today's video, we're going to learn all about the derivative, right? What even is a derivative and how can we contextualize it in terms of when given any question? We're also going to learn about tangent lines. So what are they? How can we apply them? How can we find the equation of a tangent line when given any function? And then obviously there's going to be a worked out example in relation to tangent lines, and obviously a lesson summary at the end for you to take notes on if you missed anything. Again, derivative notation, another reminder that derivatives can be written most commonly as, f prime x, for the first derivative, f double prime x, etc., or d dx, and then the function, and then equal to the derivative. So this is just another really small reminder about derivative notation, and so you remember how to write a derivative appropriately. Um, so now we're going to start talking about the derivative. So the derivative is basically an instantaneous rate of change, or in other words, the rate of change at a point in a function's graph. Again, this is denoted by f prime, f double prime, etc. It depends on what derivative you're trying to find. Like f prime represents the first derivative, f double prime represents the second derivative, and so forth, so on. So it depends on what you're trying to find. And then again, d over dx, dy dx are also used. It depends on the variable that you're taking the derivative with respect to. And then, so for example, if you're given a function, right, function ax plus c, then the first derivative of that function will just be the a and then plus 0. And this is because, a represents a coefficient, right? And so the derivative of that function is just going to be the coefficient itself, and then plus 0, because the derivative of any constant is equal to 0. So that's a really important fact to remember here, going forwards as well. So with the derivative, there are a lot of important derivative rules and a lot of things to memorize. But if we can truly understand the concept of a derivative, that it does mean the instantaneous rate of change or rate of change at a point, then it's going to be easier for us to truly understand and be able to apply these derivative rules when given any question. So firstly, we have this, we found the first derivative of this function ax plus c in the previous slide. But the second derivative of this first derivative, right, a plus 0, is just going to be 0 itself, because when we tried to take the first derivative of this function ax plus c, it was just the coefficient itself, right? The first derivative of that function is just the coefficient itself, and then the c turns to 0 because the derivative of any constant is 0. Well, the second derivative is just going to be 0 also, because the a was a coefficient, but now it's a constant, and so that's why it turned into a 0. The second derivative is a 0 here because of that fact, that the derivative of any constant is equal to 0. And that's represented by this fact that, if given a function f of x is equal to c, then f prime x is equal to 0. That's basically the same thing as saying the derivative of any constant is equal to 0. Secondly, if we're given a function f of x is equal to ax plus c, then the first derivative is equal to a plus 0, right? As we discussed, the coefficient itself. Then, here's another thing. So if f of x is equal to ax to the power of n plus bx plus c, so this is basically the structure and format for mostly any polynomial function you're going to see. when it's given to you. For any polynomial function, the first derivative of that function would be the power, n here, times the beginning of the function, and then that power gets subtracted by 1. So whatever number that is, it's applicable to that. And then just plus b plus 0. And that's because, b is a coefficient, so it drops down, and then the derivative of any constant c is equal to 0. So that's how we do that. And this is seen by the power rule as well. So that is really important to remember and be able to apply. So now we are going to dive into tangent lines. So a tangent line is basically a line that represents or has the slope of a function at a given point. And it crosses a function's curve at one point only. It can help represent the instantaneous slope at a point because it's a line that represents that same slope at a point on a function's graph. And so this concept of a tangent line is very important to understand for the AP exam, as it's going to be asked a lot, right, within the exam itself. And the exam standards also have a lot of standards covered that are in relation to tangent lines. So here is a really commonly formed or structured or asked AP question. In an AP exam, you might be asked this in an FRQ. So we are asked to find the equation of the tangent line to the function. We're given a function here, f of x is equal to 2x squared e to the x, given a point on the function's graph. We're given a point -2, 1.08. So generally, when you're given any question that's structured like this, or any question that's asking you to find the equation of a tangent line to the function, and they give you the function, then they give you a point on the function's graph, right? Generally, these are the steps to follow. So first, you have to take the derivative of the function provided. Second, you will have to find the slope of the tangent line, right? That's represented by the variable m, by plugging in the x value from their given point into the derivative function. And whatever value you get from that is going to be the slope m, right? So after finding the slope of the tangent line m, you plug in everything you have as of that point into the point slope form equation, which is y minus y1 is equal to m times x minus x1. So this point slope form equation is really important to remember as well, because anything in relation to tangent lines that they'll ask, you will need to be able to understand, memorize, and be applied this equation right here. The last step is, again, get the equation of the tangent line, simplify if needed. Usually AP scores, the AP curriculum accepts if the equation of the tangent line is in point slope form. There is no need to simplify to slope intercept form. So it is completely fine and acceptable if once you get the equation of your tangent line, you just leave it in point slope form. You do not need to convert or go the extra step to simplify to slope intercept form where it's y is equal to mx plus b, right? You can just leave it like this. There is no need to simplify and waste time. So again, let's continue working on our example. So the first step is to find the derivative of the function provided, given the function was f of x is equal to 2x squared e to the x. So we use the the product rule to solve for the derivative here, because this function 2x squared e to the x is a function that is the product of two functions, 2x squared and e to the x. So again, we find the derivative of the first function times the second function plus the first function times the derivative of the second function. And again, a really important derivative rule to memorize is the derivative of, e to the x is just e to the x itself, right? So that is one thing that stays common throughout the course. So that is an important thing to memorize. So as we find the derivative, we go on, say f prime x is equal to 4x e to the x plus 2x squared e to the x. And again, we can simplify by saying f prime x is equal to 2x, right? We factor out the 2x here, times 2e to the x plus x e to the x. And this can be simplified further, but for now, this is how much we're going to simplify it within this equation. So the second step would be like to find the slope m of the tangent line. So for this, we need to plug in the x1 value or the x value from their point which they gave to us in the question, which the point they gave to us was -2 comma 1.08, where the x1 or x value is -2. So if we plug this x value of -2 into the derivative function, then we get the slope of the tangent line, right, m, is equal to 0. So our third step right now would be to then plug everything that we have as of this point in time to the point slope form equation for the equation of the tangent line. So again, remembering that the point slope form equation for any equation of the tangent line is y minus y1 is equal to m times x minus x1. So again, we just plug in, right, the y value from their point, which is y minus 1.08, is equal to the slope of the tangent line, which we found was to be 0, times x plus the x value, which is 2. I mean, the x value was -2, but here, since it's minus minus, it becomes a plus, so it's x plus 2. Again, an important thing to remember is because this is already in point slope form, we do not need to simplify further and convert this equation to slope-intercept form and spend time on that, because on the AP exam, on an FRQ, you'll have a certain amount of time for each question. So it's really important to go as fast as possible, but also get the answer right and all the steps correct. So we're going to talk about the point of tangency here, because when we're discussing the derivative and tangent lines, it's also important to discuss a graphical viewpoint, which is the point of tangency. So this point of tangency is basically a point where the tangent line meets with a point on a function's curve. And this is usually seen on a function's graph along with the tangent line graph. So if you're ever given a graph and you're asked to find the point of tangency, it usually you can see it easily, because it's the point where the tangent line, when it's graphed, it meets with a point on the function's curve. And again, it's just in the form of x comma y, so you can just say that. So within our example here, I have put a section of the graph of the function they provided, which is f of x is equal to 2x squared e to the x, shown in that image. And within this graph, we can see that the purple line represents the tangent line, and the red curve represents a curve within the function's graph. So here we see easily that the point of tangency is seen here, where the tangent line, the purple line, right, meets with the function's curve, the red curve, at that point. And so that point is going to be our point of tangency, ultimately. And it's really important to see a graphical viewpoint rather than, just having these definitions and everything, because we will truly need to be able to contextualize, apply, and remember all of these rules, all of these facts, and tips and ways to solve problems within the AP exam. So it's really important to be able to graphically visualize what you are solving for and what you are actually doing. So that is why I've put this graph in here, to better help contextualize and visualize the situation. And that was it for this video. So within today's lesson, the derivative and the tangent line, here is a summary. So basically, again, we've discussed derivative notation, right? D over dx, or f prime x, f double prime x, where f prime x, or a derivative, represents the instantaneous rate of change at a point. And remembering again, instantaneous is at a point, right? So instantaneous rate of change at a point is basically the rate of change at a point. And then we also discussed the concept of a tangent line, where a tangent line is a line that crosses a function's graph at a point, and it represents the slope of the function at that point. So it has the same slope of the function at that given point. So that is why its purpose is so important within calculus. And then again, some steps, some basic steps to find the equation of a tangent line given a function and a point that is within the graph of that function is to first differentiate the function provided, find the slope, right, of the tangent line. So, and then you plug in the information you have at that point in given time into the point slope form equation, which is y minus y1 is equal to m times x minus x1. Then you have to simplify in the end, if possible or if needed, but you will not need to spend more time and convert that to a slope intercept form equation, which is y is equal to mx plus b. You do not need to do that usually. So once you find the equation of a tangent line, that is it. You're done. And the point of tangency, again, is where the tangent line meets the function's curve at a given point on the function's graph. And this is really important to understand and contextualize as well. So that is it for today's video in the calculus series, right? AP Calculus AB and BC series. Hope you guys understood the concept of the derivative and tangent lines and the point of tangency, because these are all crucial concepts that will come in handy on the AP Calculus exams. So thank you, and please like, share, and subscribe to not miss out on any notifications or any new videos that I will post within this calculus series. And yeah, have a great day, everybody.